Okay. Good afternoon and welcome to Mr. Michelmurray's Maths World. This is the way it is. Today we're looking at the derivative of the exponential function. You'll find more details on page 287 of your text. Now, here's the thing. If we've got a function that's an exponential function where a is just some coefficient or other, we can say the derivative of that function is simply the derivative of the index put out front. You leave the coefficient there and repeat exactly the e to the gx bit. You do not subtract one or modify the index in any way, shape or form. Now that leads to the astonishing result that if your function is e to the x, that is also its derivative. The derivative of x is 1, so there's an invisible 1 there, and you repeat the e to the x part. That's what makes the exponential function extremely useful in calculus. Let's look at some other examples. Here, all we're going to do is find the derivative of 2x minus 1, put it out front, and maybe just in brackets, and we're done. So the derivative, f dash x, let's leave the 3 there. Let's find the derivative. Oh, it's just 2. E to the 2x minus 1. Obviously, we'll simplify that to say that the derivative is equal to 6, e to the 2x minus 1. What you're going to need to do is make sure you don't overuse the quotient rule or the product rule. This one looks like it is a quotient rule problem, but it's not really, because we can divide top and bottom by e to the power of 2x. And so when we do that, we're not doing the calculus yet, I'm just rewriting or re-expressing the function. E to the 3x divided by e to the 2x is just e to the x. And minus, what have we got here? E to the 1 minus x. Now we're going to subtract 2x, so it's going to be e to the 1 minus 3x. And now that's very simple. It's going to be very simple to find the derivative of that. So f dash x is equal to, well, the derivative of e to the x is e to the x. And what have we got here? We've got the derivative upstairs being negative 3. Now, minus a negative 3 is going to yield a positive 3e. And once again, we do not touch the index. Leave it as it is. This, you might be tempted to use the product rule. You'd be mad, because what you can do is expand out the brackets. So now we're changing to equation notation here. We've got 2e to the 3x times that is going to be 2e, adding our indices. We get 3x plus x is 4x minus 6 times 2 is 12e to the 3x. So differentiating term by term in the usual way, we get dy dx, or to mix it up a bit, I might use y dash, equals 4 times 2 is 8e to the 4x minus 36e to the x. Alright, so don't overuse the product rule, quotient rule, because it's much more complicated. Here it's unavoidable. We will need to use the product rule. Now here, remember the product rule. If y equals uv, y dash equals uv dash plus the inverse of that, which is vu dash. Now in this case, u would be 3x and u dash would be equal to 3. The v would be equal to e to the power of 2x. V dash would obviously be 2e to the power of 2x. So the product rule is nice and simple. We can use cross multiplication. uv dash plus vu dash, like that. So dy dx in this case would equal uv dash is 3x times 2e to the 2x plus 3 lots of e to the 2x. Now we've got a bit of tidying up here, but that's all. In fact, not much tidying up at all. We've got 3x times 2 is 6x, e to the 2x plus 3 e to the 2x. You could factorise that, but that's not required. In fact, I wouldn't do it. You might make a mistake. All right, so there's a variety of problems about finding the derivative of the exponential function. We will leave it there. Thank you. Good afternoon, and welcome to Mr. Mukavara's Maths Bloopers. This is the way it should have been. I have 36e to the power of x. It should, of course, be 3x. Thank you for listening. Goodbye.